as Brahmatirtha was saying, my background, I have a PhD in physics from Vanderbilt University, Nashville. And then I was a postdoctoral fellow at the University of Chicago, and got a little disillusioned with academia and am now in the data science world. But I'm still fascinated with cosmology, and I still even like to just go into the backyard and look at the night sky. And when you look at the night sky, it seems almost quite mechanical. There are some stars moving around, but it's pretty static, you know? It's very predictable. But the universe itself, on a larger scale, is incredibly vast, mysterious, and bizarre. Space itself is dynamic. Space itself can warp and stretch. As Einstein proved, space, just empty vacuum space, has energy. Time may not be linear, so time can move in cycles. All these interesting things happen when you start going to really large scales. So just a quick history lesson. In about the 1920s or so, we had our first powerful telescopes, and Edwin Hubble peered out into the night sky and noticed these little island universes. What they turned out to be were galaxies like our own galaxy, but really far away. And not only did he see what people were calling island universes, but he saw that all of these galaxies were rushing away from us at the exact same speeds. So that implies that the universe was growing. And up until that time, we all thought the universe was just static. It just was what it was eternally. But now it was dynamic. It was moving. So what does that mean when a universe is growing in time? If you run the clock backwards, that means it probably started at one point. And that's what brought rise to the idea of a Big Bang. If you're growing and you reverse it down to time equals 0, you have this initial thing that starts everything off. And that's what was called the Big Bang. Mathematicians and physicists didn't really like this because it involves sort of like this infinitely dense point where something comes from nothing. There's really no explanatory power, but it's what we all settled on, and it had a cool name. Later on, in about 1999, a really bizarre thing happened. So when you take any volume of space and it's filled with stuff and you make it bigger, that stuff under gravity will make it slow down and then come back together. But when they looked out with their fancy new telescopes into the universe and saw galaxies that were even farther away, what they saw were those galaxies were moving away from us even faster. So the universe wasn't only growing, but it was growing faster and faster and faster and faster. It was accelerating. And that has some pretty big repercussions. Does that mean the universe will just expand forever into nothingness? Will we be ripped apart eventually as it just keeps expanding? What does this mean? No one really knew. And in fact, no one expected to see this. So when I was in graduate school eons ago, everyone agreed that there was a Big Bang followed by this weird thing called inflation. Has anyone heard of inflation? I know, it's a little esoteric. But it's just this very, very tiny period at the early part of the universe where things swelled really quickly. The universe got really big, really fast. And it solved all these outstanding problems in cosmology. But it left a lot of other problems. In fact, it left philosophical problems, metaphysical problems. Because one of the things that comes out of inflation is another idea you may have heard of called the multiverse. Have you heard of the multiverse? This is the idea that if inflation happened, then there should be an infinite number of other universes that came into being. But we can never prove that. So we're no longer in the realm of empirical science. So that theory is really troublesome to a lot of scientists. But then when you turn to Vedic cosmology, it's extremely rich, extremely intricate, profound, and very well laid out. And it's not just driven by sort of empirical observations. It's a whole different epistemology altogether. So they can answer questions that science simply can't answer. So why do I care about cyclic cosmology? Well, again, when I was in grad school, you had this one universe that expanded and just keeps on expanding. And what a lot of prominent scientists are leaning towards now, in fact, Nobel Prize winning scientist Roger Penrose has put forward, is that no, we can solve a lot of these problems if we consider a cyclic universe, one that comes into being, eventually annihilates itself, and then starts over again eternally. So this is no longer fringe science like when I was in grad school, and is now very mainstream. And we're talking about chairs of departments at Princeton and others really, really pushing these ideas of a Vedic, well, not Vedic, but of a cyclic cosmology. And to me, no matter what they put forward, there's a fundamental limitation. And that is, they can't tell you why it's doing that. All they can tell you is that mechanically this is happening. But why is it happening? There's no information there. So this is a unique opportunity for scientists in the devotee community to start looking into the Vedic tradition. There's so much in there that we haven't extracted that can give details into how the universe actually operates and why it is the way it is and how it is the way it is. So it's not just a question of, okay, the universe gets bigger and smaller and then starts all over again. In fact, it's much more rich than that. It's how does space even come into existence? How does time start? How are they related? How does the material universe come from wherever it comes from? We can provide answers to that, or at least, I hope that wasn't Raleigh. Provide a rigorous framework within our understanding of Shastra for a Vedic tradition of cosmology. And the idea is not to say, let's conform what we think to what science is telling us right now. That would be a very dangerous thing. Because if we did that 10 years ago, we'd look like fools. We need to stick to what we're finding within our own texts to basically form a rigorous mathematical picture of how the universe evolves in Vedic cosmology. And I think, in my mind, as a scientist, I would find this extremely intriguing if all I knew was modern physical cosmology. I'd want to know more. I'd want to know, wait, you guys already said that one cycle of the universe is 311 trillion years? How do you know that? Because our models are saying that the universe is about that long in distance and lifetime. It's about 200 trillion years. How do you guys know that? And how did you know it was cyclical? It's very intriguing to outside people where we have this beautiful picture of the cosmos that we can present. And so I would want to say that in progress, this is a cross collaboration. There are people from other fields within devotee working groups that help in this arena. So people working on consciousness, neuroscientists, historians, people that know a lot of philosophy. This is all extremely relevant. And what's really cool is going forward in February, we'll be having a workshop strictly on basically the origins of the cosmos, the fate of the universe, etc., from the Vedic tradition. It's bringing together PhDs in all different fields, including cosmology. Krishna Abhishek will be there giving a talk on the epistemology of cosmology. It's just a really neat time. It's a lot of people collaborating on something where we have a lot of potential to present this to a general audience and to the devotee community in a way that they can digest it. So the research is still ongoing, but I'm obviously excited about it, and hopefully you guys want to learn more. So yeah, stop there. Oh, and I will say on a side note, I think you had asked me to mention that I'm also interested in doing an updated version to Sadaputa's Maya book, The World as Virtual Reality, because since his passing, this has become a very mainstream topic in academic philosophy. You get your Elon Musks and your Neil deGrasse Tysons talking about this all the time. And Sadaputa laid it all out there, but there's a lot of new stuff to add to it since he wrote that book. So I'm interested in doing an update to that.
Thank you very much.
Thanks, guys.
Are there any questions? I'll seed it with one. So when does the universe start collapsing, according to the modern theories?
Depends on